the equation of a straight line will always be given by y minus y1. And then you have, this is equals to m, the gradient, then x minus x1. This will be the expression that gives us a straight line. So in other words, here, if you have the gradient of a line, if you have the gradient of a line M, and one point on that line, any point, one point on that line, let's say x1, y1, then according to this expression, we can determine the equation of that line. All we need is the gradient of that line and any point on that line. So this is all we need to come up with the equation of a straight line. Now, apart from this, so yeah, this is going to be one useful equation. Now, let's start with tangents. If you look at tangents, if you're given a curve, a tangent is going to be a line that cuts the curve at only one point. That is what a tangent is. Now, to get a tangent, if you're given a graph, let's say like this, I think we looked at this some time back. To get the tangent at any point, the gradient of the tangent, the first thing that you'd have to do is first get the gradient at that particular point. Let's say you wanted to get the, find the tangent, the equation of a tangent at a particular point there. But what you know is the function here, f of x. So the first thing you have to do is to differentiate this function f of x. Why? Because you know that the derivative of a function gives you the gradient at that point. So the derivative of a function at a given point gives you the gradient of that function at that point. Now, the gradient of that function, it will be equal to the gradient of the tangent at that same point. So even though I differentiate the function f(x), when I get the gradient function, when I get the gradient, that gradient will be the same as the gradient of this tangent line. So the first step in getting the equation of a tangent of a function is to first differentiate a function. Now, a good example would be, say you have y is equals to x squared minus x minus 2, or instead, let me use the questions that Kangwa gave us. Let's look at the questions that Kangwa shared. Let's quickly get this one. Okay, so picture, let's try to find an easy one. Okay, yeah, let's pick B, for example, for our easy example here. So since I'm starting with tangents for now, so I'll focus on tangent lines. So check, for example, you have f of x is equals to 2x to the power 3 minus 3x plus 7, and they are specifying at a point 1, 6. So the first step is to get the gradient. You don't even have to sketch this, but the first step is to get the gradient of this function at the stated point. So the gradient, of course, we know to say is equivalent to the derivative of the function at that point. So when I differentiate this, what we get is the derivative of 2x to the power 3 will be 6x to the power 2. The derivative of 3x would just be 3. The derivative of 7, on the other hand, that will just be a 0. So that's the first part. We have obtained the derivative. But at this first point, our point is 1, 6. The x value is 1. The y value is 6. So the gradient then, when x is equals to 1, we'll have to put a 1 here, minus 3. This becomes 6 minus 3, and the gradient becomes equals to 3. So we get the gradient is equals to 3. What is this telling us? Well, we've got the gradient of our function f of x at the specified point 1,6. But what does this imply? It also means that the tangent, a tangent line drawn at 1, that's 1, drawn at 1,6 will also have the same gradient. It will also have the gradient equals to 1, equals to the same gradient we just found, which is 3. It will also have a gradient equals to 3. So for our tangent, already we have determined that its gradient will be equal to 3 based on our results from that derivative. Now, having obtained this, notice that we have just solved one piece of the puzzle. To get the equation of the tangent, we needed two things. We needed the gradient, and we needed 1 point on that line, on the tangent line. But guess what? When a tangent line is drawn, let me say you have a graph like this one. When a tangent line is drawn at a specific point, the question actually gives you what this point is. In this case, it is 1,6. Since they give us what this point is, well, this lies on the function on the graph is meaning that once we have the gradient, we can easily use that relation y minus y1 is equal to m, then x minus x1, and use this to get our equation of the tangent. Y here remains, but this is y1. This is x1. So y1 is 6. Then the gradient, we have just found the gradient is 3. And then x here, then we have minus x1. And our x1 is a 1. So you have 1 here. So this becomes y minus 6 is equals to 3x minus 3. So that you can conclude that y is equals to 3x minus 3 plus 6, which is y is equals to 3x plus 3. This becomes the equation of the normal at that point. Now, this is how we get the equation of the normal. No, not the normal, sorry. The equation of the tangent at that point. It's the same thing even with the other functions. It starts with you differentiating. When you differentiate, then when you differentiate, substitute the x value in that derivative. After that, then then use y minus y1 is equals to mx1, x minus x1. Then you're done. So do you want us to do another example on the tangents, or we can go to the normals? Do you want another? We go to? Okay. So this is how it works. The only difference, of course, with the other questions is some of these are, when it comes to differentiating them, we need to be a little bit careful, because I think this is straightforward as well. This is also straightforward, but for these we'll have to use those complex differentiation methods, product rule and so on. But nothing too difficult there. Now let's look at normals. Now, in most cases, normal lines are mentioned on their own, but to answer them, you have to relate them to the tangents. Because if you're given a curve, the starting point is for a curve. When you differentiate, you get the gradient of the tangent. But the tangent relates to the normal. And I think this relationship, we saw it earlier on. If M1 is the gradient of a tangent, or if M1 is the gradient of one line, gradient of tangent, and M2 is the gradient of the normal, gradient of normal. Now, both these, this normal is at the given point. At the given point. What you have to understand is that if let's say we get this curve here, if we were to get this curve here and use this as our example for the normals. So let's look at this one. Since we're now looking at the normal at this point, it will have to be a perpendicular line to the tangent. That is what a normal would have to be. A normal can be seen as a line that goes like this one, but it's not just like this. It's a line that stretches not just there, but it stretches all the way like this. So this is the equation of a normal. Not the equation. This is how a normal would look like. But the point I want to just drive home here is the relationship between the normal and the tangent. These two lines are perpendicular to each other. These two lines are perpendicular to each other. So we kind of forget that this is a normal, this is a tangent. All we want to take advantage of is the fact that they are perpendicular. Now, how does it go? Well, if two lines are perpendicular, one line has gradient m1, the other line has gradient m2. If they are perpendicular, then the product of their gradient will be equals to -1. This is if the two lines are perpendicular. Now, of course, if lines are parallel, it means that their gradient will be the same. So look out for such tricks. Sometimes when they want you to get the equation of a line, they'll say this equation has this equation is parallel to an equation which looks like this. So they'll give you a different equation and say it is parallel to the line they're looking for. So if they are parallel, then you know they have the same gradient. If they are perpendicular, then their gradients will relate in this way. So take, for example, our question. Let's say the tangent has m1, and in our question here, we found the gradient of the tangent was equals to 3. It then implies that here, we can easily get the gradient of the perpendicular line. So whereas m1, we'll put 3. Then m2 here is equals to minus m1. So that based on this, our m2 becomes equals to -1/3. This becomes the gradient of the normal at that point. Now, having found the gradient of the normal at that point, we can easily come up with the equation, because guess what? Even to come up with the equation of the normal, we only need one, its gradient, to one point, any point really, along that normal. And we still have this 1,6, so we can still use it. So even for the normal, we can still say y minus y1 is equals to m, and then we have x minus x1. And we're still using 1,6, so that this is y minus 6, but the difference is the gradient. Our gradient now is 1/3, and then x minus 1. So that this becomes, I can cross the 3 here, so that it becomes 3y minus 18 is equals to minus x plus 1. So across the 3, I've set a negative in. Okay, great. So from here, we have 3y, then minus 8. The 18 can go the other side. So this is minus x. Then we have plus 1 plus 18. So that we have 3y is equals to minus x plus 19. And then if you want, you can divide then by 3, so that we have minus x plus 19/3. We can leave it like this. We can say y is equals to minus x/3 plus 19/3. Or we can leave it like this. So we have come up with the equation of the tangent. This is the equation of the normal. Earlier on, we saw the equation of the tangent. So that's the relationship between the tangent and the normal. And for all the equations, the questions that Kangwa shared in the group, this is the approach that we'll be taking. Differentiate, to get the gradient of the tangent, then use that gradient with a given point to find the equation of that tangent. Then once you're done with that, you can then move on to the normal. For the normal, use that the product of their gradients will be equals to -1 to find the gradient of the normal. Then use that gradient with a given point to find the equation of the tangent. So not the tangent, of the normal. So I think we're going to end it there. In the next class, what we're going to do is we'll try to find more interesting questions. These ones I feel are actually very basic. I'll ask you guys to try them out. I will be awake for a little bit longer, I think up to midnight or so. So if you guys you can try these. If you're not sure, you can send them to me. I'll be happy to review them for you. But in our next session, I'll try to find tricky questions where they are asking us to use these properties to answer certain questions. So look out for those. If you come up with them, if you find them or come across them, feel free to share them with me so that I can add them as I prepare for the next class. Okay, so any questions before we end? Okay, so we can end here, you guys. You guys can have a good night. We'll see you guys on Friday night.